Okay, guys, like I was saying earlier, today we're just going to spend some time reviewing and making sure you know how to find all of these things on a parabola. Sometimes a parabola is called a quadratic function. You have to be able to identify vertex, axis of symmetry, and roots. Those are the most important things on a parabola. Okay, vertex. Now there's several ways to find it. There's a calculator way, there's a completely brain way, and there's my favorite half brain, half calculator. Do y'all remember how to find vertex? What do? Opposite of b over 2a. That's the brain part. You actually have to figure out the opposite of b over 2a. Then comes the calculator part. Then you look in your calculator's table of values to see the y value that goes along with that x value. Okay, so that's the best way I prefer. So let's do vertex. What's the opposite of b in this problem? Positive 2 over 2 times a, and a for this problem is a 1. What's 2 divided by 2? 1. So now I know part of my vertex. This is the brain part. I figured it out by doing the opposite of b over 2a. That's the x value of my vertex. Here comes the calculator part. I go to y equals. I put in my function rule. X squared minus 2x minus 3. Then I look straight at my table of values. Whatever is across from an x value of 1, that's the other part of my vertex. So what is it? 1, negative 4. That's one of the most important parts of a parabola. That's its turning point. That's the middle of the graph. That's either the highest or the lowest that it's ever going to get. So then I gave you a little grid. You would come over to your grid and you would put a dot at positive 1, negative 4. There's my vertex. Is that going to be the lowest or the highest for this picture? It's the lowest. I know this is a smile because a is a positive number. That means this is a smile. And on any kind of smile or any kind of parabola that opens up, the vertex is the lowest point. Okay, axis of symmetry. We're already done. What is the axis of symmetry? Okay, now it is 1. However, if you just tell me 1, I can't give you credit because that's not an equation. Yeah, x equals 1 is the axis of symmetry. It's the equation of a vertical line that goes straight through the middle of the graph. So since we already knew the vertex, we really already knew it. It's just the x value of the vertex, x equals 1, and that's a vertical line that goes through 1 on the x-axis. That just helps us find mirror points. That's why it's useful. One of the reasons why it's useful. Okay, so we got vertex. We got axis of symmetry. The next most important thing is roots. What's another word for roots? Zeros. What else? X-intercepts. Roots, zeros, x-intercepts. In other words, we want to know when is it going to cross this x-axis. We could do factoring sometimes. Sometimes it's factorable. We could do quadratic equation always. And we could do calculator always to find roots. I really want you to get good at the calculator way. And there's even more than one way to do it in the calculator. The way I taught you was you have to put in y equals 0. This is the part kids forget. If you're finding the zeros, you must put in a 0. And then you see where these two functions, one of them is actually the x-axis and one of them is our parabola. We want to see where they intersect. Here's another place where kids make mistakes. They don't hit enter enough times. You have to make sure you hit enter every time it asks you a question. First curve, second curve, guess. Make sure you hit enter until you see the word intersection. So what's one of the zeros here? Negative 1. It's crossing the x-axis at negative 1. So one of the zeros is negative 1. And if you wanted to write it as a point, it would be negative 1, 0. Now I got to find the other one, the one over here. How do I make my cursor go over here? I want to hit the right arrow, but you really need to hit trace first, hit the right arrow, and get that cursor over to the other side. Then you do the whole thing again. Second function, calculate, intersection, first curve, second curve, guess, 3, 0. The other 0 is right here at 3, and as a point we would call that 3, 0. Now I have a pretty good idea, at least of the bottom of this curve. And then I asked you to graph it. Now, your graph will be better if you include more points. Where could I find some more points? Yeah, if I want any other points, all I got to do is look at the table of values and then just graph some of them. Negative 2, 5 should be on your picture. You can kind of use the axis of symmetry to find the matching point on the other side. And once you've got, a few points, then connect your dots. I know my picture's not perfect, but don't judge me, I won't judge you. But it should look something like that. The shape should be generally like this. The y-intercept should be right. The zeros should be right. It's definitely a smile opening up. The two most important things that I want you to know how to do is vertex and roots. Now, on yesterday's homework, they also asked you about y-intercept. Just for fun, what's the y-intercept? Negative 3. That's this number at the end. That means it's crossing the y-axis at negative 3. I didn't draw my picture perfectly, but it should be crossing the y-axis at negative 3. And then the mirror point across from that would be right here. Okay, are we good with that? Because that's pretty much what's going to be on your next daily grade. I'll give you like maybe 5 equations, and I'll ask you to find the vertex, roots, and I might possibly ask for axis of symmetry. Are we going to be okay with that? Okay, normally we would grade homework, but let's go ahead and get the lesson done. All we're really doing today is reviewing this, and I just want to look at some of the situations you might encounter. Okay, so we're going to look at some of the some different situations that you might have with parabolas. Otherwise referred to as quadratic functions. How can you tell from an equation if your graph's going to be a parabola? How can you tell just by looking at the equation? Well, if you only have the equation, though, and not the picture, it's definitely a parabola is a U shape, either facing up or facing down, like a smile or a frown. But if all I have is the equation, how can I tell it's going to be a U shape? Excellent, Cindy. It has an exponent of 2. If you've got an exponent of 2, that's a parabola. If that's your highest exponent, y equals x squared with anything else in it, that's a parabola. That's a quadratic function. Okay, now this one is a pretty simple parabola, but I want to show you something weird that happens on this one, which we have talked about, but we haven't really looked at graphing one like this. First of all, what do you think I'm going to ask you to do? Well, definitely you got to be able to graph it. How would you begin to graph it? You got to find the axis of symmetry. What else? The vertex. What else? The roots. Okay, so let's do that because something weird happens on this one. What do you want to start with? Axis of symmetry. Okay, now remember, on axis of symmetry, it's the equation of a vertical line. So it must start out x equals. If you don't put the x equals, I cannot give you credit because a vertical line has to have the x equals part in it. And the way we find what it equals is the opposite of b over 2a. What's the opposite of b here? 6 over 2 times 1, which is what? 3. So how would I report the axis of symmetry to my math teacher? X equals 3. And on my graph then, I would come over to 3 on the x-axis and draw a vertical line right through that 3. That's the middle of my graph. It helps me find points, mirror image points. It also helps me find the vertex. How does it help me find the vertex? Yeah, the vertex has to be on the axis of symmetry. That means we're already halfway done with the vertex. It has to have the same x value that the vertex does. But the vertex has something else. The vertex isn't a line. What's the vertex? A point. We already found the x value of the point. Once we found the axis of symmetry, we have found the x value of the vertex. We're halfway done. That was the brain part. Now we do the calculator part. So we go to y equals. We put in that function rule. Y equals x squared minus 6x plus 9 And I'm going to look straight at my table of values. I know the x value of the vertex has to be a 3. What's across from a 3? 0. There's my vertex. Just for a quick review, there was also a way to do this vertex in the calculator. Besides doing it half brain, half calculator, there was a way to do it completely in the calculator, but there was a reason why I didn't like that way. Do y'all remember? It gives you a weird x value. The exact x value is always the opposite of b over 2a. Plus, you have to know if this is a minimum or a maximum. If you look at the calculate screen, you can calculate a minimum or a maximum. And that's the vertex, but you have to know what you're looking at. What kind of parabola should this be? It's a smile. So that means that the vertex would be the minimum point. So let's just do this real quick. Second function, calculate minimum. In this method, it asks you for left and right boundaries. So if it's asking you for a left boundary, look at where your cursor is. It's got to be to the left of the vertex, the left of the middle. Is it to the left right now? Yes, so I can go ahead and press enter and it'll put a little arrow up there. Then it asks for a right boundary. You just have to get over to the right somewhere. As long as you're over to the right of the vertex, press enter and an arrow pops up. It asks you for a guess, press enter again. And sure enough, it gave me a weird x value. Sometimes it might tell you 2.9999. This one told me 3.000001. But the exact x value is what? 3. It does give you the right y value. The vertex is at 3, 0. Okay, is that weird to you guys that the vertex is at 3, 0? Why is that weird? Okay, this does have roots. This is one of the special cases I wanted to talk about. It does have roots. What's the y value on any root? 0. Well, what's the y value on the vertex? 0. So guess what? How many roots does this thing have? 1. This was one of those weird cases where it only has one root. The vertex and the root are actually the same point. Okay, now, let's say I didn't notice that and I wanted to find the roots with the calculator. Here's the part kids forget. If I want a root, I've got to put in y equals 0. Because a root is the same thing as a 0. I'm finding the zeros. Do second function, calculate, intersection. First curve, second curve, guess. Oh, it's telling me 2.99. Why did it do that? That's weird. I've never seen it do that before. Second function, calculate, intersection. First curve, second curve, guess. Well, the answer is exactly 3, 0. Okay, so the root and the vertex were the same point in this problem. That means the turning point actually happens once you get to the x-axis. It starts turning as soon as it touches the x-axis. So every once in a while, you're going to have the same point for root and same point for vertex. That's not something that happens all the time, but that you will encounter that. If this were a factoring problem, I'm just going to tell you what this would have factored into. If we were trying to find the roots by factoring, which was what we learned way before Christmas, this is what it would factor into. We get the same two factors, so we get the same two solutions for x. Okay, so this is one of those weird cases where the root and the vertex are the same point. Now, if I asked you to graph it, this isn't going to help you graph it. So far, all we know is one point on this graph and the middle of the graph. How could I find some other points real easily? Table of values. If you look at the table of values, you've got millions of points that are on this graph. And you just graph some of them, connect the dots. What's a point that's really easy to find just from the equation? 9. What is 9? What's special about 9? The y-intercept. So it's real easy to find the y-intercept point on any function. So I'm going to go up to 1, 2, 3, 4, 5, 6, 7, 8, 9 and put a dot. That helps me with my graph. Plus, I know that I've got to be 3 spaces away over here, knowing about the axis of symmetry. So at least that helps me get a better picture. Okay, so vertex, roots, axis of symmetry. In this problem, it was easy. It was pretty much all the same. Okay, do you remember another weird case that you might encounter? no roots. Let's look at one like that. Y equals negative x squared plus 4x minus 7. Okay, every parabola has to have a vertex, and every parabola has an axis of symmetry. Not every parabola will have roots. So, what you've got to be able to do on your next quiz is identify all these things for me. Vertex, axis of symmetry, roots, if there are any. And then if I want a picture of it, you probably want to give me some additional points that you just look at your t-chart and write down points and then graph them. What else might I ask for? A real easy point I might ask for. Y-intercept. What is the y-intercept of this thing? Negative 7. The y-intercept is super easy to find. Okay, let's start. What do you want to do first? Let's do vertex first. The vertex, I prefer half brain, half calculator. Opposite of b over 2a, then look in your table of values to see the y that goes with it. So you do the opposite of b over 2a real quick. Who can tell me the x value of the vertex from your brain? Isaiah. The x value of the vertex is absolutely 2. X equals 2 for the vertex. Okay, good job. That's the opposite of b over 2 times a. Negative 4 over negative 2 is 2. Now, how do I find the y that is matched with that 2? Yes, this is the calculator part. You go to your calculator, you put in the function rule. Please make sure you enter it correctly. Y equals negative x squared. Oops, I didn't enter it correctly, did I? Y equals negative x squared plus 4x minus 7. My x value is a 2. What's the y that goes with it? Negative 3. So there's my vertex. That's one of the most important points on a parabola. So if I was sketching a quick picture, I would come over here, I would go right 2, down 3, boom, there's my parabola. There's the vertex of my parabola. All right, axis of symmetry. We're already done with that pretty much. How would I write the axis of symmetry? It is 2, but don't just put a 2. What do you put? X equals 2 is the axis of symmetry. So now I know that that vertex has to be the exact middle of the graph. It goes right through that point on the x-axis. Roots. Okay, let's talk about this thing. Is this going to be pretend like we didn't have a calculator for a second. Here's my vertex. It's below the x-axis. Is this thing a frown or a smile? It's a frown. How do I know it's a frown? Because a is negative. So that means this thing's going to go down. So I know it's going to go down even if I didn't have a calculator. So what does that tell me about the roots? There are none. Plus, if you take a look at it in your calculator, we put in y equals the function, look at it. It's never going to cross the x-axis. Let's say we didn't know that, and we went to find our roots. We go to y equals. If I want to find the roots, which are also called the zeros, you must make sure you put in y equals 0. Put in the function, put in y equals 0. We're going to calculate where it intersects. What's my calculator going to tell me? It's going to tell me error. It's trying to tell me, hey, there are no zeros here. No sign change. Plus, if I had looked at the picture to begin with, I would have seen it never crossed the x-axis. So sometimes you're going to have a weird situation where there are no roots. But one point is not going to help me graph this picture. What's the really easy point to find, which we already talked about? Y-intercept. 1, 2, 3, 4, 5, 6. Negative 7. Put a dot at negative 7. Put the mirror image point on the other side of the axis of symmetry. And then you can at least give me a really basic picture. Okay, so one weird case is when the vertex and the root are the same point. Another weird case is when there are no roots. That does happen. Okay, and then the last kind of weird case I want to do, it's not really a weird case, but it's when the intercepts are not nice whole numbers and not nice decimals either. They're weird decimals. So let's do one like that real quick. Yes. F of x equals x squared plus 2x minus 7. What's f of x mean? Y. Okay, same thing as y. Is this a smile or a frown? It's a smile. How do I know it's a smile? Because a is positive. The number in front of x squared, if it's positive, you got to smile. If it's negative, you got to frown. Okay, what do you want to find first? The vertex. Okay, opposite of b over 2a, brain. Find the y that goes with it in the calculator. It's not going to have a nice vertex either. It's going to be a decimal, I believe. Oh, maybe not. What's the opposite of b here? Negative 2 over 2 times 1. So what's the x value of the vertex? Negative 1. Find the y that goes with it in your t-chart. Y equals x squared plus 2x minus 7. Look at my table of values. What's across from negative 1? Negative 8. It was a nice vertex. Okay, so now I can at least put the vertex in the right position. Go left 1, down 8. There's my minimum point. It's never going to get any lower than that. What's the axis of symmetry then? The axis of symmetry is not just negative 1. X equals negative 1. So now through that vertex, let me just draw a vertical line that goes through the middle of the graph. A vertical line always starts out x equals. Okay, what's next? Roots, otherwise known as zeros. So to do this in the calculator, you've got to put in y equals 0. If you forget to do this, it's not going to work. You can't find the zeros until you put in y equals 0, this, at least with this method. Second function, calculate intersection. It looks like one of the roots will be around 2, and the other one should be around negative 4-ish. Let's see what happens. First curve, second curve, guess. 1.828. Was that real close to 2? Okay, so one of my roots is 1.828. So if I were going to graph that, I would come over almost to 2 on the x-axis. Not quite to 2. It's a little bit before the 2 on the x-axis. How do I find the other one? Do the same thing, but I got to get my cursor over here. Hit trace. Move that cursor to the other side. Do second function. Calculate intersection. First curve, second curve, guess. Negative 3.828. Negative 3.828 is the other root. That's almost to negative 3, but not quite. Okay, so now I know where it's crossing the x-axis. What's another point that I can find real easily? The y-intercept. What's the y-intercept? Negative 7. That means it's crossing the y-axis at negative 7. I can find the mirror point over here. Okay, and again, you got to forgive my picture. It's not perfect, but at least I have a general idea of the shape. And if I wanted some additional points to make my shape better, where could I get some other points that are on this graph? From the table of values. Any of those points, I could put a dot at those points and then connect the dots, and my picture gets better and better with the more points I include. So are you guys good with that? You've got to be good at those skills. Vertex, axis of symmetry, roots. Okay, go ahead, and your homework's going to be a worksheet tonight, another worksheet. Go ahead and get out to last night's homework, and let's get that graded.